Welcome again, guys. Today we're going to look at series and Sigma notation, right? And then if you just have a look at the top of the page there, it says um, the mathematical symbol sigma, that's what we call sigma, is a capital letter S in the Greek alphabet. It is used as the symbol for summing a series. Did you hear that? It is used, so I'll underline what I'm reading. It is used as the symbol for summing a series. Okay, and then it says consider the following series. So now we've got a series. On top of the sigma is a small letter n, and underneath that we have k, right? And then the general term is tk. So how your series is gonna look is that you're gonna have term 1 adding with term 2, adding with term 3, adding with term 4 maybe, and then you're gonna get the last term, which is represented by tn. All right. Now, the next sentence there, here, that's where I'm reading. It says, this is read as follows. The sum of all terms, right? The sum of all terms, tk, which is the general term. Okay, from k equals 1 to k equals n, where n is an element of natural numbers. So maybe you didn't catch everything that was taught in that first paragraph, but just continue with me and you understand what this means. Let's look at example number 12. It says they calculate, and then you've got your sigma notation, right? So you've got 7 at the top, you've got k equals 1 at the bottom, and your general term sits here. 5k minus 3, that's your general term. So it says here the solution is, translating the expression is as follows. Start with k equals 1. So that is the starting point. The number 1 is the number that you're going to start substituting. It says start with k equals 1 and substitute all integers from 1 up until 7 into the expression 5k minus 3. This term, the term on top, is the number of terms, right? The number 7 is the number of terms that you're going to substitute into our general term. Okay, now it is simplify each substitution and then determine the sum of the numbers. Now let us have a look at this part here. Right, so 7 right on top of the sigma sign says there the last value. It is the last value to be substituted into the general term. Okay, the general term, which is our formula, is 5k minus 3, and you'll see there's the arrow there. All right, and then the very first term to substitute into our general term is 1, because k equals 1. So all of these things here are important. All of them are important, right? So make sure that you understand what is what. I'll go through them again. The number on top of the sigma sign, which is represented by n, is 7, and that represents the very last number that you're going to substitute into your general term. And then the number at the bottom, which is 1, you see there where k equals 1, that's the very first term that you're going to substitute into our general term. And then 5k minus 3 is our general term. Now, let us start substituting. Where are we going to start? With the first value to be substituted, where k has a number. So k equals 1. So we're going to start with 1. Okay, so let's have a look at our general term. 5k minus 3. So our answer is going to be 5 open bracket 1, because that there is the first term to substitute into our general term, and then the minus 3 is already there, so you just include it. And then that there is our first term, right? That there is T1. Let's have a look at the next term. What follows after 1? It's 2, right? So in the place of k, we're going to substitute the number 2. And so 5, open bracket, 2, close the bracket, minus 3. And we do that until we get to 7. You see we've got 3 in the next one. And we've got 4. And then we've got 5. And then we've got 6. And then we've got 7. Now, what is our last term? 7. It's the number right on top of our sigma sign. Do you see that? And then what you can do from here is take each bracket, put that in your calculator. If it's not such big numbers that you don't have to guess the number out of your head or calculate manually, then you can just use your calculator. But here we know that brackets mean multiplication. So 5 times 1 is 5, minus 3, that's 2. And so 5 times 2 is 10, minus 3, that's 7. And there it is. And then 5 times 3 is 15, minus 3, that's 12. And so you go, right? And then from there, because this is a series, so you looking for a sum, you looking for wait, let's go and have a look at our first paragraph. It says it is used as the symbol for summing. Summing means getting a total, right? So we're getting a total of what this series is. And so you add all of those numbers and you get 119. Okay, so that there is your answer. So now that was if you look at your numbers there, see, look at this here, look at that there, look at that there, look at that there, you probably notice something. There's a difference that's consistent, right? There's a difference that is consistent, and that difference is 5. If you take 7 minus 2, you get 5. If you take 12 minus 7, you get 5. If you take 17 minus 12, you get 5. Do you see? So that's the pattern. And if you remember something about first difference, then you would come up to something like arithmetic. So this here is an arithmetic series. Now let's have a look at the next example. So we've got example 13. Excuse me, example 13. And here we've got calculate, and it says it gives us a sigma sign. Our n is 7. N is the number on top, right? Our n is 7. And then we've got our r equals 0. So that's our starting point. And our general term, which is basically a formula, is 3 times 2 to the power of r. You see that dot between the 3 and the 2? That means multiplication. Okay, so now we're going to apply the very same rules that we applied for our arithmetic series right above. So now let's see. We've got our starting point is 0. Remember, the starting point is what's underneath the sigma sign. We start with 0. Okay, so let's take our general term and start substituting. We started with 0 right here in this bracket here. There's 0, and then you've got 1, then you've got 2, up until the last term. Remember, where is our last term? Where is it found? Right on top of our sigma. That's where it is. Do you see that? So you need to start where the bottom of your sigma says you must start, and you need to end where the top of our sigma says we must end. And so it goes. And now you could do this in your head, or you can use a calculator. but it's easy. So what you do is you need to remember BODMAS. You need to remember, so in this case there aren't any brackets in the general term, so the next thing is orders. Orders have to do with your exponents, and so we do have an exponent here. So what is attached to the exponent is the 2. So 2 has a power of 0, and anything to the power of 0 is 1. You see that? And so 3 times 1 is 3. Now let's have a look at the next one. So 2 to the power of 1 is 2. And so 3 times 2 is 6. And 2 to the power of 2 is 4. And so 3 times 4 is 12. And so you go, right? And then remember, what are we looking for? Sum. The sum. So we are summing the series. And so that's how you find the answer. So you have to add all of them together. Now, if you look at this pattern, it's different to the one before. There we had a constant difference where we saw that we were adding 5 the whole time. But here, there's something else. It's called a ratio. So this here is a hint that this is a geometric series. All right. And so that's how you do your sigma. And so just to recap from the top, right? So series and sigma notation, the mathematical symbol S is the alphabet, well, the capital letter S in Greek alphabet, right? And so it is used as a symbol for summing a series, as a symbol for adding all the numbers for a series that is given to us. That's what that means. And it says consider the following, and it give us an example there. Well, you've got sigma, you've got n on top of the sigma, and then you've got k equals 1, and then you've got tk. All of those represent something. And we saw that the n is the last term that you're supposed to substitute into our pattern. And then k is the very first term that you have to substitute into our pattern. And then tk is the general term where you're going to be substituting our values for k. So for instance, we've got tk and then k equals 1. So we start with t1. And then the next one is 2, and then the next one is 3. And because we don't have a value for n, we're just gonna have an ellipsis and then n, because that's where it's supposed to end. Okay, and then it says this is read as follows: the sum of all terms tk, which is the general term from k equals 1 to k equals n, where n is an element of natural numbers. And then we looked at our example, which is example 12. We've got 7, which is our last term that we're going to substitute into this pattern. And then we've got k equals 1, which is the first term that we're going to substitute into our general term. And then we're going to find our sum, which is the total. Now it says translating this expression is as follows: start with k equals 1 and substitute all integers from 1 up to and including 7. The expression 5k equals 3. So we're going to substitute from 1 up until 7, and then it says simplify each substitution and then determine the sum. Do you see that? We are determining the sum of the numbers. The sum is the total. There we did it. We substituted 1 first, and then we came with 2, and then it was 3, and then it was 4 up until 7, and then we added those and we multiplied in the brackets, and then we had a total of 119. And then we applied the exact same thing when it came to example number 13. We took the first term, that's the last term, 7 is the last term. We took the first term, which is r, and we substituted in the place of r, and then we went up until the very last term, which is 7, and then we added all of those together, and we found the answer 765. And then it says there, take note that the number of terms in the above series is actually 8 and not 7. So let me say this, and you'll see this in the next lesson. The number of terms, right? So this is T1. Let me write there on top of it. This is T1. This is T2. This is T3. This is T4. T5. T6. T7. And T8. All right. So those are 8 terms. You see n is 7, but the actual terms here are 8. Why is that? You'll see in the next lesson that there is a formula to find out how many terms there are in this pattern. But an easier and shorter answer is that we started at 0 and not 1. So you start at 0 and not 1, so we count 0. If you start counting from 0, you'll find out that there's an additional 1 in that pattern. And so that's about it for this lesson, and I'll catch you in the next one. Right.